Hi, everyone. I know we didn't have a chance to go over the stats portion of the lab and your homework, so I'm going to take a second just to show you some of that now. We're looking at your statistical analysis homework sheet, and please read through it. I mean, this is probably not completely new to you folks, but go through background. There are a few questions on the first page, like what are different types of data, what's qualitative data, what is discrete quantitative data, and what is continuous quantitative data. So qualitative data is a little bit more descriptive, right? Like if you're describing your colonies, versus discrete is actual numbers, and usually it's like 1.2. They're not necessarily always whole numbers. But it's like, how many eyes does an individual have? Whereas continuous is something that's like height or weight, where it's not really bounded by anything, although there are usually limits to some of those things like height and weight, but it's not, you could be 126.4, you could be 360. So it's on a continuous scale, okay? So pick which one of these categories that you're describing for what we've used in class. And then as you go down, reading more about sampling and replication, different measurements of variability, and how to calculate out some of these different things. So I'm going to switch from this to actually show you what our data looks like for this semester. So the data has already been posted on Blackboard. Please use that data. You cannot use your own data for your group or for the class. It needs to be the data that is coming from all 7 sections of the biology labs, okay? So these are the things that we're going to calculate, and this is not on the sheet. This is something that you are going to be calculating on your own. So when you look at the sheet here, you will be able to see the different sections, the numbers, the groups. Ultimately, we don't care about any of this, right? It's just our way of organizing it, but really what we care about is we have a before count an after count of colonies for the soap and water treatment. We have a difference that's calculated there. Notice that the only negative numbers are ones that had a higher after count. So these are probably pretty significant outliers. The chances that you have dirtier hands, and I mean, that's pretty subjective, but the chances that you have more bacteria on your hands after washing your hands with soap and water and or hand sanitizer should be 0. Something probably happened here, whether it was mislabeled or possibly some extra contamination from something, someone touched something, whatever it might be. Just keep that in mind, that the only negative numbers here are the ones that had a higher after, which is probably not usually the case. You can see here, but we do have a few of them. So I would probably consider these numbers to be some of our outliers, and then some of the ones that have very large numbers in comparison or even very small numbers could also be considered outliers. But we have the difference here, and we also calculated out the percent effectiveness. So percent effectiveness, you can see, is just the difference sorry, it started cutting me off there for a second, but percent effectiveness is the difference divided by the before times 100. So percent effectiveness, obviously for some of the negative ones, it's going to be kind of weird, but you can see 91% effective, 87% effective, 80%, 10%, and so forth. And then we have the same thing over here for hand sanitizer treatment, before, after, the difference, and the percent effectiveness, okay? So if we're coming down here, now you folks are going to have to calculate out all of this. So for N, that's basically just how many samples do we have. And obviously you could just count this, but there is an easier way to do it in Excel. Anytime you want to enter in a formula in Excel, you need to use the equal sign. For counting what our N is, you can write in count, parentheses, and then all you're going to do is highlight this. Okay, highlight it, close the parentheses, press enter. So you can see our N was 37. To give you an idea, if you're not super familiar with Excel, we can do this for every column, right? We can enter in this formula, or what you can do is you can just drag this here, wait until you have this little plus sign here, and then drag it all the way over. And then you will get the calculation for each one of these. Keep in mind, you might want to make sure that you check on one and look up here and see that it says, okay, count E6. So here we're in column E through 42. So you actually did drag the formula over, you didn't just drag the number. With all of these other ones, it shouldn't be the exact same number, right? Our N just should have stayed the same throughout the whole experiment. For mean/average, it is referred to as a mean in most cases, so please refer to it as that, but it is the same thing as an average. You can calculate out the average by typing in average, parentheses, again, highlight all of the data, close your parentheses, and press enter. I'm not going to do it so that you guys can calculate this out on your own. For standard deviation, it's going to be equals standard dot deviation. I think dot deviation, maybe not. Oh no, not dot. Standard deviation. I'm going to use this one down here. Oh, nope, it doesn't like that one. Okay, and we're going to use standard deviation for the sample. Okay. If yours is one of the older versions and you can do just standard deviation, you can go ahead and do that, but otherwise do standard deviation or stdev.s for the sample. Again, highlight all of your information, go from there. For standard error. Standard error is not on Excel, so what you're going to need to do for this is you're going to have to divide the standard deviation by the square root of the number of replicates or N. So what you can do is you can do equals, you can click on this normally. Oh yeah, see, this is letting me click, I think because it's too big, but click on SD, not the mean or average, and then you're going to divide that by, and for this you'll have to type in SQRT for square root. Again, parentheses, I would just click on N, close the parentheses, enter. And that'll automatically calculate out your standard error. And again, you can just drag it over all the way so that it just calculates everything for you and you don't have to keep entering it in. For variance, I think they do go through how to calculate out variance in your handout, but what you could do instead is make it a lot easier. You can type in variance dot or var. Okay. Variance.s, highlight all of your information, close the parentheses, enter, and then you will have your variance. Okay, so that should give you that. Again, you can drag it all the way over here. Now, once we have all of this data, you can answer a lot of the questions that are on your handout. So everything that you need to have is here. So it'll say below these two columns, calculate out this. It's saying only to calculate it out for 4% effectiveness because that's really the only thing you need to do it for. But if I were you, I would just calculate out the whole thing. It's really not that hard. Once you type it in once, again, just drag it over. And then the main ones that we really are concerned about, again, are percent effectiveness for each treatment. What you could do if you want to get rid of the rest of this is you could just maybe copy over these two. Copy, oh, I can't do it because it's a merge though. So copy over these two, you can just highlight down from here, control, highlight down from here, copy these all the way, and then you could create new page if you wanted to just clean it up, or you could just delete all that, but probably easier just to leave it all on here. That way you can see all the data in case you need to. But you're going to calculate all of that out. And then you're going to answer the questions in here, right? What is the soap and water in, hand sanitizer in? Again, those should be the same. What is the mean for each of these? What is the standard deviation? What is the standard error? Oh, so you, yeah, oh yeah. So these are asking you based on the percent effectiveness. Okay, so you're not just writing out, you're not using the difference or either of those before or after means, you're using percent effectiveness. Okay, so keep that in mind. You're then going to use this data to create a bar graph in Excel and compare the two means. So make sure you label your X and Y axes, make sure that everything is very clear. You have a title and description below the figure, and you can also add the table that can go with the graph, but remember the table title and description go above the table, okay? So that is something that you will have to include with this homework. You can make that in Excel and then you can transfer it over to Word if that's a little bit easier, or that is for sure easier to write the title and everything like that. There is a video from another instructor that you should watch on how to do that. If you have any questions, please let me know. So now we're getting to the fun part and we're going to test for statistical significance. So if you've never used any sort of stats before, then this might be a little bit new to you, but you probably have all heard of a t-test. There are many different kinds of t-tests. There's one-tailed, two-tailed, and two-tailed means that we're basically looking at the difference between two means statistically, whether they're the same or different. And there's a few things we get from a t-test. One is a t-statistic, which is just a t-value, and one is a p-value. Okay, there are some other things that we get too when you run this test, but those are the two that we're really looking for because that determines whether or not we can support or reject our hypotheses, basically. So the more variable our data, the smaller our sample size, the more likely we will not be able to determine any difference. So the higher our probability is going to be, which is not what we want, right? Ideally, we want the probability very low, which is why we set our alpha value or our p-value at less than 0.05, which basically just means that we can reject our null hypothesis and that the means are different and they're statistically different. So we're 95% sure. There's less than a 5% chance that we're wrong, essentially, okay? Keep in mind that this does mean significant. So if you can back it up with stats, you can say it's significant or statistically significant, but it doesn't necessarily mean it's biologically meaningful, or we wouldn't say biologically significant, but basically just that it matters in statistics, but maybe biologically it's, you know, we're not really quite seeing that in the wild or something, which is probably not something you would really talk about too much with this experiment, but you are welcome to say it is statistically significant if you run the t-test and it has a p-value of less than 0.05. There are a couple different types of t-tests. Again, one is paired, one is independent. We actually have both paired and independent samples in this. For example, we have paired samples where you did a before and after, where it was the same person measuring bacterial colonies before and after the treatment, whether that was hand soap or hand sanitizer. So that is an option, but that's not really what we're looking for, right? Obviously, we should see that there is a difference between those. We should see less with after treatment. That wasn't always the case. Remember, we do have some outliers, but we're not so interested in that. That should be a pretty obvious statement. What we are interested in is soap and water more effective at removing bacteria than hand sanitizer? So to do that, we would actually be doing an independent sample t-test, okay? So here's the formula for an independent sample t-test. There are a couple ways that you can do this. In order to calculate this out, I would recommend typing all of this kind of step by step. So what you can do, I kind of started doing it here. And again, we're only going to run our t-test on this data. So let me just highlight it because this is what we care about, is the percent effectiveness data, okay? I know I'm not really highlighting all the same stuff, but that's okay. So for the t-test, again, let's see. I can show you kind of both of these at the same time. Hopefully you can still see them pretty well. Okay, let's do this. Okay, so for our t-test, it's t equals the absolute value of x1 minus x2. And x1, x2 are the two means of our sets of data. And then s squared 1 and s squared 2 are variances. So the sample means 1 minus 2 over the variance of 1 divided by n1 plus the variance of 2 divided by n2, and we take the square root of that whole thing. So I would chunk this up into little bits. So again, x1 minus x2. So you can calculate out the absolute value. To take the absolute value of these two, you have to type in, I think it's absolute, yeah, abs, right? And then we can do this, and we're going to do x1 minus x2. So we'll call this one x1, this one over here x2. So it would be this minus, we'd have to scroll over a little bit here, this, and actually that's not the right one. This is n, so we would do it for the mean, which, just to not confuse you, let's do that. This one minus this one. Oh my gosh. Okay, well. Yeah, L45. Okay. It's showing a 0 right now because we don't have the mean calculated, but all you have to do is that. That'll give you the absolute value of those two. And now we want, I just called this S here for simplicity because I can't give it the super sub quotient, but variance, we have S1 over N1. So we're going to equals, and we're wanting this divided by this, right? And again, these numbers aren't showing up because you're going to calculate it. We're going to do the same thing for the variance. And then we can put the whole thing together down here. So we want equals this number, sorry, it's off a little bit on mine, divided by the square root, SQRT, of this number plus this number, and we get that equal. And again, it's not going to show up right now because we don't have anything up here, but that is one way you could do it. You can also do it this way down here, where you type in the t-test. Okay. So you can do equals t.test, right? And now we're going to put in this information. So we're going to select all of the data in column 1, which would be our percent effectiveness from SOAP 1 from SOAP. And then we're going to put a comma, oh, sorry, that was really hard for me to say, a comma there, and then we're going to select all the data from the percent effectiveness for hand sanitizer, comma, and then we're going to put in a 2. Okay, and that just means that we're doing a two-tailed test, and then 3 is telling Excel that the variances are not equal. Okay, we're going to close that. We're going to press submit, or press enter. And now you have your T value. Sorry, I misspoke. This is your P value. This is your probability. So your T you're going to get from this calculation here that we just typed in. Your P value is right here. So if we were actually using just this small subset of data that I did, again, this is not accurate for yours, our p-value would be 0.5, and our alpha we have set at 0.05. So based on what I just did, this would not be statistically significant, okay? So please make sure that you do that. If you don't want to calculate out your p-value like that, which I would say that's probably the easier way, instead you can use the table down here. So this gives you the critical values of the t distribution. So you do need to know your degrees of freedom. Your degrees of freedom, you can calculate out, degree of freedom is always n minus 1. So since we have two different ones that we're using here, two different samples, it would be the n of your soap effectiveness minus 1 plus the n of your hand sanitizer effectiveness minus 1. So we know these are both 37, so 36 plus 36. So we've got 72 degrees of freedom. So we would come down here somewhere between 60 and 120. So it gets a little bit difficult. And then we have to look for what our t statistic is, okay? And once we get kind of close to that, that's when we can look at what our range of p-values are, okay? So again, whatever way is easier for you. If you've learned a certain way, I have not calculated out the t or the p values yet, so I can't give you a much better example on that, but it is something that you can do if you would rather not type this into Excel to get your p-value. Alternatively, if you've ever used Excel before and have downloaded this, if you go to data and data analysis, you can see data analysis tools. I would recommend maybe doing this after you did everything that we just did. And what you could do is you could also run a t-test. I would assume I would do it as a 2-sample, assuming unequal variances. So we can click that, press OK. Oh, it's working, but I think that, there we go. So for variable 1 range, I'm going to want to select all of these. I'm not going to select actually all of them right now, just so that you actually do it on your own too. But variable 2 range, again, we will select all of the % effectiveness data from hand sanitizer. This is from the hand soap. And then hypothesized mean difference. We do not have a hypothesized mean difference. Alpha is 0.05. We can put it in a new worksheet. So I'm just going to press OK. And now it's giving me all of this information. So I would do everything that we did before just to make sure that this is accurate, because it might not be if you do it the wrong way and you don't want to be wrong. But this gives you all of the information. So it gives you the mean of both of these variables, okay? Gives you the variance, so you can double check those two. Tells you what your observations are, so that's your n, right? So you can see it, we only did a, 14 and 15. I didn't even do them evenly. And then that'll also give you your t statistic, which is one of the things we really want to know. The other one that we really want to know is our probability, okay? Let's see here. Probability on one tail. So I know one of you was asking, how can the stats be different, or how would you get different answers depending on your hypothesis? We technically have a one tail hypothesis, because most of you have predicted that you would have less bacteria on the hand soap treatment than you would on the, or your % effectiveness would be greater on the hand soap than it would for the hand sanitizer, but there were a few of you that thought the opposite. So technically, we could go either one-tailed or two-tailed. If you just thought there would be a difference, that would be two-tailed. But I think all of you technically were one-tailed, in which case we do have a significant p-value. It's 0.03, okay? This does get kind of confusing, especially if you haven't worked with this before. So I'm just showing you it because I know that a lot of you probably have done this, whether it's in Excel or some other sort of stats software or SPSS, whatever it might be. But please calculate it out this way. If you want to play around with it and see if you get the same answers or just double check your work, maybe try the data analysis in Excel and see if you get the same numbers that you did when you calculated it out over here. Okay. I know that's kind of a quick version, and obviously you're also going to be using this data to then go and insert a chart. Don't do a recommended chart. Make sure that you're doing the right kind of bar graph, but you're going to come over here, do your bar graph, and then you're going to, again, this is not exactly what you're doing, but then you're going to take this and put it in Word so that you can actually accurately put it all together. Okay. Please watch the other video by the other instructor so that you understand how to do this completely. And if you have any questions, please let me know. Thank you.